Watch this swarm of stars, pulled together by nothing but gravity. They orbit, they swing past each other, they dance. And every so often, one gets flung clear out, racing off at tremendous speed. There's just one rule at work here, and no one aimed that shot.
One rule threw a star out of the whole cluster?
Gravity alone, plus a lucky close pass, can launch a star. Spin the cluster faster or pack it tighter, and the dance changes, but those ejections keep happening. Let's meet the rule, and watch the slingshot for ourselves. The rule is just gravity, every body pulls on every other body. The closer two stars are, the harder the pull, it grows as 1 over the distance squared. That's the whole law, no thrust, no targets, each star only feels the tug of all the others.
So nothing is steering them, they just fall toward each other?
Exactly, and with many bodies, that simple pull turns surprisingly wild. Let's zoom in on just 3 stars and watch one real close encounter, slowly. 2 of them swing in tight and start whirling around each other, a pair. The third falls in toward the pair and dives through the whirl. In the tug-of-war, the pair often drops into a tighter, faster orbit, handing energy to the third. That kick flings the third star away, faster than it arrived.
So the pair tightened, and the loner got thrown out?
A close 3-body pass, that's the slingshot. Back to the full swarm. Let's name what you're seeing. Each glowing dot is a star, and the faint tail behind it is the path it just took. The bright crowd in the middle is the dense core, where orbits are tightest and the close encounters happen.
So the trails show where each star has been, and the core is the busy part?
Read it that way, and the chaos becomes a crowd of falling bodies. Let it run, and the cluster breathes, stars plunge through the core and swing back out. No 2 runs are ever the same, nudge one star a hair, and minutes later the whole dance differs.
All of that from just gravity?
One law, many bodies, and the motion never quite repeats. So why does a star get thrown out, instead of all of them just orbiting forever? When 3 meet up close, 2 of them can pair off and fall into a tighter, faster orbit. The pair loses orbital energy, and the third star carries it away, speeding off, sometimes fast enough to escape for good.
So the pair pays for the launch by drawing closer together?
Right, the binary usually tightens, and the loner is flung out. That's what's called the gravitational slingshot. Change how it starts, and you change the dance. A slow spin lets the core collapse and fling stars hard. A faster spin flattens it into a swirling disk. Use only a few stars, and you can follow each orbit by eye.
Same one rule each time, only the opening throw differs?
One law of gravity, a whole zoo of clusters. And this isn't just a toy. Close gravitational encounters can fling real stars right out. Runaway and hypervelocity stars, tearing across the galaxy. It's also how we send spacecraft outward. A probe swings past a planet, borrows a little of its motion, and slings onward. It helped send the Voyagers to the giant planets and onto escape paths. And 3 bodies under gravity are famously unpredictable. The 3-body problem has no general simple formula.
So a spacecraft and a runaway star ride the same trick?
Gravity, 3 bodies, 1 good kick, and away you go. So next time you picture the stars, don't picture them fixed. Picture them falling around each other, trading pushes and pulls. And now and then flinging one of their own off into the dark.
No engine, no aim, just gravity.
Give a crowd of stars one law, and they will launch each other.